Most students think prime factorization is just a boring drill until they see what it actually unlocks and solves. From simplifying fractions to finding HCF and LCM, these problems look totally different, but they all share the same powerful idea. In class, we show students how to break any number down to its prime building blocks, and suddenly, even the trickiest questions become almost too easy. Let's start with this exercise. Suppose that a and b are positive integers with the value of a greater than b, and with LCM equals 462 and GCD equals 33. Find all possible values of a and b. Got it? Let's see how TCA solves the exercise.
Practice 6 states that suppose that a and b are positive integers with a greater than b. Okay, so this is important for the answer. A must be greater than b. Okay, A more than B. They say that the LCM of A and B is 462 and the GCD between A and B is 33. And they ask you to find all possible values of A and B. So this question is different in the sense that instead of giving you the two numbers and they ask you to find the LCM and the GCD, they give you the LCM and the GCD and ask you to find the two numbers. But they also say find all possible values. What does that tell you? There are multiple answers. Let's help ourselves, okay, and express the LCM and GCD in prime factorization. So 462, just 2, we get 231. 231 is just 377, 7, and 11. So 462 is 3 times 7 times 11. Okay, 36. So this is the LCM. The GCD, 33, is just 3 and 11 to get 33. Okay, so it is just 3 times 11. So let's take a look. Okay, the LCM is 2 times 3 times 7 times 11. The GCD is 3 times 11. We need to find possible values of A and B. When the GCD is 3 times 11, that means both A and B must have 3 and 11. Right? Because GCD states that we need to take the common factors. Okay? So let's give both A and B 3 and 11.
A has to be bigger than B.
A has to be bigger than B. So let's talk about the remaining factors. There's still a 2 and a 7. If I multiply 2 and 7 to this one to get A, will we get 462 as the LCM and 33 as the GCD? Take a look at these two numbers. If this was A and this was B, will we get that as your LCM and GCD?
Yes.
You will? It will work, right? Okay, so this is definitely one possible answer. Okay. And it's also correct because A is more than B, right? A is 14 times more than B. Okay? But is there any other answer? Okay, we still need to both have 3 and 11, right? Because that's the GCD. So that's a must. They must both have 3 and 11. Can I increase the powers of any of the factors? So what we can do is have A and B still have 3 times 11. But if we multiply the B with the 2 and the A with the 7. Is this correct? But the GCD says that we just need to take the common factors, right? And if you look at A and B, the common factors are still only 3 and 11. A and B is 3, 11, 7, 3, 11, 2. To find the GCD, we'll still take common and lowest power. Common is just 3 and 11, right? So we'll actually still get the same GCD, okay? And as for LCM, is that you just need to take all factors. So you'll still get 3 times 11 times 2 times 7. And that is the LCM, correct? So this one is correct because A is also more than B.
So, this is our final answer. You did great on the first exercise, Math Champion. Now for our next question. Try it on your own first. The product of 315 and x is a perfect cube. What is the smallest possible value of x? Also, don't forget to like and subscribe. Now, let's look at how TCA solves the problem.
The product of 315 and x is a perfect cube. Okay, we've been dealing with perfect squares. Now we need perfect cubes. Okay, so try to make a guess. If square root divides the power by 2, what does cube root do?
Divide by 3.
Divide by 3. Very good. So if it divides by 3, that means the product of 315 and x. So do the same thing. Okay, break it down into its prime factors. See what you're missing and make it up until it is all the powers are multiples of 3. Okay, so 315. Gabriel, can you tell me how to break down into its prime factors? So 315 equals to 3 squared times 5 times 7. Okay, and they say they want perfect cube. Perfect cube means I want all my powers to be multiples of 3. Right? So to make 3 squared into a next multiple of 3, we want 3 cube, right? We will just times 3. 5 into 5 cubed, we will times 7 times 7 square. Okay, so once we multiply it, we will get 3 cubed times 5 times 7 cubed. All the powers now are multiples of 3. So when you multiply numbers, the power will increase, right? Therefore, your smallest possible value of x is just this number. Can you see that? So therefore, smallest possible value of x is 3 times 5 squared times 7 squared equals to 3 times 25 times 40. So 3 times 25 times 49 is just 75 times 49. 49 you can change it to -1, right? 75 times 50, what will we get?
3750.
Yes, it'll be 3,750 minus 75. Okay, so that should give you 3,675.
So the final answer is 3,675. Wow, you learned quickly. TCA is so proud of you. Now, try this on your own. 3,375 divided by m is a square number. What is the smallest possible value of m? Leave your answer in the comments section. Well then, till next time, Math Champion.
If you would like to learn more from these tutorials, please smash that like and subscribe button.